Good. If you're heading somewhere else for the next session, go for it. Otherwise, I'm going to pass it over. Nate Good is the Chief Technology Officer for Idelic, and he will take us away for the next 30 minutes. Thank you, Miguel.
My pleasure. Thanks, everyone.
All right, yes, thank you, Miguel. I'll try to live up to that. It'll be hard. Going. So the obligatory, can you nod if you can see my screen? Yeah, yes.
Okay. Looks good.
Great. Well, thank you everyone for joining. It's great to be back at an event like this. I even put on my fancy sweatpants for the occasion. I'll spare you guys from seeing them. Yeah, so today here to talk a little bit about using AI, machine learning to help bring drivers home safely. My name is Nate Good. I serve as the CTO for Idelic. Idelic is a software company that uses data aggregation from disparate sources of data, applies machine learning to those data to help commercial trucking fleets make sense of their data, make sense of their business. And probably the most important way we do that is by helping them get their drivers home safely. We'll talk a little bit about how us and others in the industry are doing that momentarily. Just again, the obligatory agenda here. We'll talk a little bit about truck crashes and why that's bad. Hopefully that's straightforward. We'll start easy, but then talk I think about the more interesting stuff, which is how we're applying AI and ML to make the likelihood of those accidents a little bit less frequently. And lastly, we'll kind of talk about kind of being socially responsible in the world of AI and ML. So to start, hopefully we'll start off with the obvious, like I said, but as you might imagine, large truck crashes are a pretty serious problem. When you have a vehicle that weighs 40,000 pounds barreling down a highway at 65 miles an hour, that can be potentially a recipe for disaster. So there's the data we have here from NHTSA is, in 2018, so the last time they reported this, we had over 500,000 large truck or bus accidents. And of those led to actually, unfortunately, over 5,000 fatalities. So right off the bat, just from a purely kind of safety and wellness perspective, this can be a pretty serious and challenging problem. And that in and of itself should be enough to want to take action. It certainly is, from my perspective. But if you put aside even the safety aspect of things for a moment, this can be rather problematic for a business as well. These are very expensive pieces of equipment, very expensive trucks. On average, even when you're looking at all accidents, even small accidents, the average cost of an accident can be $120,000, roughly speaking. And that number obviously, unfortunately significantly jumps up to well in the millions if there are serious injuries or fatalities. In our business, we have what's known as the nuclear verdict, which is kind of in the case of a lawsuit after an accident, where the kind of plaintiff is awarded, I think it's upward of $10 million. We consider that kind of a nuclear verdict, a very large sum of money tied to an accident. And in many cases, that can be enough to shutter an entire fleet and obviously contribute to lots of job loss and other concerns. So I have officially started off with probably the most depressing start of a presentation ever. I promise it'll get less depressing here, and we'll start talking about some of the more interesting stuff, which is, we've identified the problem, right? This is a serious issue we need to address and causes real challenges, both from a safety and business perspective. So the question is, how do we apply AI and ML to actually help solve this? I think probably the first one and the obvious one that people think about, and obviously one that Miguel spoke about a little bit if you were here for the earlier talk, was kind of how we apply computer vision to help with the problem. So going to show an example here. This is one of our partners. We work with Netrodyne, and probably an example that I think when most people think about computer vision in cars, they would think about, especially when you start to think about the world of autonomous vehicles, which is simply putting a front-facing camera on a vehicle and helping to make sense of the image they're seeing, looking for objects. In this case, identifying the backs of cars, but also looking at kind of the lane itself. And so while a lot of our trucking fleets that we work with aren't necessarily using this for autonomous vehicles and autonomous driving, they certainly are using that for understanding the driver's behavior. And so detecting things we would call highway observations around a lane departure, or we would call a near miss, someone getting very close to an object or another vehicle. And all of these can be useful signals that usually get pushed up in near real time to alert a safety manager that maybe you have a driver that is getting a little sleepy behind the wheel. They're swerving in and out of lanes, and we can detect that in real time with computer vision. Or maybe this is just a driver who maybe needs some training in general. They've not quite figured out all the necessary skills to maneuver a very large and difficult vehicle to drive. And so we want to make sure we have those events that we can track and use computer vision to do that. The alternative to this is what we would call in our industry a ride along, which is predates the AI version of this, which was you would literally, if you suspected a driver had some challenges, you would literally put someone in the cab with them to have a ride along. And to Miguel's point as well, that obviously doesn't scale. So this has given us a way for us to kind of scale using CV. The other side of this, which I think people don't think as much about, is the cameras that are inside the cab. And so for us, this means not just looking at what the driver is doing on the road, but also the attentiveness of the driver in general. This is another great example from a partner we work with, Idelic, that has an internal facing camera on the driver. And in this case, you can see we're detecting if that driver is distracted. As you probably are well aware, distracted driving is often you hear about it kind of spoken in the same terms as drunk driving, and that it can be just as dangerous. So we want to be able to detect that and make sure that we know if you have a driver that has a tendency to, like in this case, check their phone, play with the radio or some other screen in the cab, or also maybe getting dozing off, that sort of activity. So obviously when we think about a lot of times with AI in the world of kind of safety and trucking is the CV side of things, looking obviously outside the vehicle, but also almost equally as important what's happening inside the vehicle, and then using all of these as signals to help us make sense of the overall kind of safety profile for a driver. If you're interested in this kind of thing, obviously there's, I'm sure, plenty of you on the call of familiar with some of these libraries and tooling. Obviously, using things like TensorFlow and Keras get a lot of attention. The I guess OG in the space, OpenCV, also use a lot for this. If you're really just interested in kind of dabbling in some of this, I've made a goofy video of myself and some just facial recognition, landmark detection type of CV that can be fairly easy with this library here. And so you can dabble and see what it would be like to create your own model, train your own model to detect distracted driving. So moving on, probably one thing that people don't think as much about with safe driving is NLP. Obviously, another very large section of the machine learning kind of area of expertise. And this is an area that we've had some experience with. My colleagues and I have some experience with kind of looking at how we apply this to also improving the safety of our roads. So what you're seeing here is an example of something that's something that one of my colleagues worked on, which is starting to kind of take unstructured information, unstructured text that we might have from a safety manager who's maybe describing an accident or describing an incident that happened, and starting to make sense of that. So in this case, we were looking to take some unstructured text and help classify, the types of accidents, to look for patterns of behavior of what was going on with the accidents that they were experiencing in their particular fleet. And so here you see us kind of doing some of that classification of those accidents. In this case, for those that are curious, this is a case where we were using classification based on SBERT, which is sentence BERT, an extension of the BERT model that was started by Google, that does a form of word embedding to, I think Miguel also talked about this, right? Turning pictures into numbers. Well, this is turning words into numbers, right? Creating word vectors or vectors in general out of text for us to do training on. And so that's an instance of us applying that here and then doing clustering on those vectors to not only identify the type of accident, but also similar types of accidents, right? A near miss with an animal strike or an object strike are, not that far apart, and we can determine those types of things using these techniques. Another area that we've seen this start to be used in is, a lot of our fleets are equipped obviously with mics and with phones for communicating with central dispatch. And you start to now see some providers in the space doing analysis on the transcripts of these calls, right? Can we determine if a driver is distressed or there's something else going on that we may want to be aware of by looking at the transcripts of those calls. So the last main area here, which is one that Idelic in particular focuses a lot on, and we have experience with, is kind of the predictive analytics side of things, and using a disparate set of data to help make sense of the overall picture. In this case, of analyzing risk and safety. So to start off with, a quote here, one that's probably many of you have heard and maybe are tired of hearing at this point, but I think it's still applicable in this case, which is, the fox knows many things, but the hedgehog knows one big thing. I think this originally is attributed back to the Greek poet Archilochus, but then I guess made a little bit more popular by the British philosopher Isaiah Berlin. This essay about classifying the way that philosophers think and kind of as foxes or hedgehogs, right? And the idea of the hedgehog is that this is someone, again, that knows one big thing. They put kind of all their eggs in one basket. They search for ways to confirm potentially their bias around why that one big thing is the big thing and the most important thing, and go deep and focus in that one area. Whereas the fox, maybe a little bit more skeptical, is looking for as much disparate information as possible, and will try to make an informed decision based on all of the small things that it learns and knows, and is much less likely to make big, bold statements about kind of there being one truth about one way of doing things. And I think this is, obviously one good way to think about kind of predictive analytics in general, and a philosophy that I think we've applied at Idelic in particular when we think about predictive analytics, which is starting to kind of look at a broader set of information. When you look at, maybe computer vision solely in a bucket, focusing on the driving and processing of the road and maybe internally in the cab, that certainly is a really important data piece, but it does get a bit myopic in that it focuses just on that kind of real-time information that's happening right then and there in the cab, in that one, instance in time. Whereas it may be more beneficial for us to start to look and use that only as one input into a model to help make sense of the overall picture. And so this is kind of what we would call kind of the Fox approach to driver safety, which is kind of a product that my colleagues and I have worked on, what we call Safety Suite. And this is where we've kind of taken disparate data sets. So data sets like the computer vision based data sets, the cameras that are on and inside the cabs of the trucks on the road, but also looking at other sets, looking at just simply accidents history, like what is this driver's history of accidents, be it small or large, and the severity of those accidents. What is this driver's violation record? Is this someone that, sure, they maybe have a clean record from a driving perspective on the road, and they've been lucky up to this point, but they have a history of violations or citations about not keeping their truck up to code, or maybe driving too many hours in a given day, which could lead them to having other incidents. And so what we've done is, at Idelic, we take these disparate data sets, we put them through a CNN, a neural network, to help us kind of to overall predict, in our case, the likelihood of an accident happening at a certain period of time. So typically what we're doing is we're looking at the likelihood of an accident happening in the next 3 months based on what we know about a driver and trying to predict that likelihood. That all things equal is a very infrequent thing. Fortunately, the likelihood of a real accident happening in the next 3 months for any given driver is only, I believe, around 2%. So we're trying to predict a very infrequent kind of sparse event. But we've seen real success by looking at kind of a disparate set, not just looking at any one specific area of data and information to help make our predictive models more accurate. So we'll wrap things up by talking a little about kind of social responsibility when it comes to AI. Obviously, I know that kind of the ethics side of AI and ML comes up quite a bit. This is not one of those talks, but I do think it's important to talk a little bit about the idea and what I like to call the good old Peter Parker principle of with great responsibility, or sorry, with great power comes great responsibility. And I think that's certainly the case in the world of AI, right? There's a lot of press about kind of borderline nefarious uses of AI, or at least in maybe a best case exploitative uses of AI. And there's some very successful businesses that build their business on what could be considered maybe exploiting the user or exploiting something or someone for monetary gain. And I think Idelic is maybe a great example of where these don't have to be mutually exclusive ideas, right? You can build a successful, profitable business while also not doing something exploitative, or in the best case, making the world a safer place, as we believe we are doing at Idelic by empowering these fleets to make better informed decisions about the safety of their drivers and when to train them, when to remove them from the road, or take other corrective action. Well, I used to work with someone in a past job that a data scientist that felt so uneasy about the fact that possibly the work, not that we were doing anything nefarious, but that the work that she was doing could be considered kind of just exploitative or not really serving a bigger purpose. And so to kind of offset her guilt, she would go and donate her time, her ML kind of experience, to nonprofits to help them solve problems as well. So it's a plug. If you are in one of those situations where you feel conflicted about the work you do, it's kind of like your carbon offsetting for machine learning and AI, is that you can always go and also donate your time to organizations that can also use the power of AI and ML for good. So that is the entirety of the talk for today. I'll open it up for happy to answer any questions you all might have for me.
We do have a question, and that was great, Nate. Thank you so much. Justin is asking, with predictive modeling, do you see any opportunities to use the findings from these data sets to inform improvements to the built environments where vehicles operate? For example, iterative design improvements to build safer roadways.
That's a great question. It's not something that we try to predict today, right? Most of our the kind of users or the fleets that we're working with are focused on kind of the current safety of their actual drivers and their fleets. And we're not necessarily working with as robotics, like directly with municipalities or other groups. But in a way, certainly, it's quite possible, right? There's a lot of information that we were picking up on these trucks. I think one of my, again, poorly preconceived notions going into this industry was that this, trucking had to be this antiquated, industry. It's you build up that kind of stereotype in your mind of what trucking is and means, and then you learn that it's actually quite high tech. All right, similar kind of aha moment when kind of peeling back the layers of the onion in the kind of agriculture space. Right, again, you think of this kind of being a not very technically savvy space, and you lo and behold learn that it's actually incredibly technically savvy. Lots of sensors, lots of machine learning being applied. So while we don't do it, I certainly see there could be a way to apply it back to iterative design. I think it's a great idea.
Another question from Jack. How do drivers respond to this intrusiveness? One company's operational improvements is one man's concern. That's a great point, and I think it's something to my earlier point about kind of with great power comes great responsibility. I mean, so while we certainly are helping the roads be safer, there is certainly a bit of a what could be perceived as an invasion of privacy on the driver.
And in some ways, like this actually kind of was out of our hands, and that the regulatory bodies that regulate kind of trucking, both at a state and national level, have put more and more kind of regulations in place to mandate this kind of fine granularity tracking. So recently, I can't exactly remember the year it went into effect, but drivers now are all required to have ELDs in their cabs, or these electronic logging devices that log exactly how many hours they're driving, how long they're driving, how long they're off the road resting, because we've saw tired drivers are probably one of the most extreme examples of unsafe drivers. And so a lot of, like, from a regulatory perspective, this has been pushed down, saying that we need more equipment on the trucks themselves to ensure safety. And I think that, so the drivers, while I think there's probably, my guess is there was an initial kind of pushback on this, at the end of the day, they are the ones that are probably more directly affected than anyone, right? No driver wants to be in an accident either. And so I think once you get over that initial, hurdle of this kind of just maybe being a new norm, you can understand that this, again, probably benefits no one more than the driver themselves, having the assistance and aid of AI to make them a better driver and reduce the likelihood of them getting into a serious accident. I think hopefully it's something that they see the value in themselves.
Thank you, Nate.
My pleasure.
Any other questions for Nate? I put his email address there in chat if you ever want to reach out to him. Jack said in general, yes, the problem, as you well know, is handling the ambiguities. Indeed,
there's no direct clean answer to all these things, right? It's a new territory that we're all navigating in the world of AI and finding that sweet spot. And I think as long as your head's in the right place and you're trying your best to find the right compromise of using data without exploiting the user and using those data for good, hopefully we do the right thing.
Justin asked again, Justin again, but first question here. Does your company use any open source data sets, or is it mostly proprietary data gathering?
So for the most part, it is proprietary first data or first party data that we're capturing directly from the fleets themselves. We ask the fleets when they come to us to provide as much historical data as possible. We're building these models not just on the current state of data, but looking back, right? As you would imagine for most kind of supervised learning, building that training set, not just for a general model, but also a specialized model for some fleets. The type of data, quality data, the frequency of those data that we are getting on a fleet by fleet basis can be a little bit different. And so there are some nuances to the models that we build fleet to fleet basis. But having said that, there are open source data sets like many industries available for this. FMCSA does provide some public information around just general high-level stats, both overall about the use of our roads in the country, the frequency of accidents, those types of things, miles being driven, and also some high-level information about on a fleet-to-fleet basis. And that's an example of a data set that we work very closely with is kind of the data coming from FMCSA, especially when it pertains to violations, citations, that sort of thing. But there's also data sets that we don't use. So I know I started the talk talking about computer vision. There, especially due to the interest and excitement in the world of autonomous vehicles right now, there are lots of great open data sets around computer vision when it comes to data of analyzing our roads, objects on the roads, and that sort of thing. So I can't recall the name of the exact data sets. There's one I affectionately like to call the car butt data set, which is just a bunch of the rear view of cars of like hundreds of thousands of cars, obviously for detecting cars coming that you're approaching. But but we use a blend of those two types of open and proprietary data.
Do customers discipline drivers based on the predictive models? Great question in the chat. Do you know of that?
Yeah, so it depends on how you want to, I don't know if I use the word necessarily discipline, but they definitely, we would call as they take corrective actions with the driver. So If we notice that I think if you recall the image, we have a histogram of kind of where your drivers fall into the certain buckets of risk. And so a lot of our fleets will have, for the people that fall into the top bucket of risk, they will likely take some sort of corrective action. That could be assigning them training, especially if they notice, hey, this is a driver that maybe is swerving a lot or is making harsh cornering. They need to be just trained on the right way to take a corner. Or it may result into, like I said, a ride along. So this is a case where enough of the AI side of things gave us enough information to say, hey, this is someone that may benefit from a ride along, and having a more experienced driver in the cab to help them for some period of time. And in extreme cases, maybe yes, if there's a repeat history of someone not improving their score, not conducting training, not taking it seriously, it may result into an actual disciplinary action from an employment standpoint. But this is mostly about how do we make our drivers better, and not how do we let go of drivers. I'd say second to safety, the biggest problem in the trucking space is retention of drivers and hiring drivers. There's a massive driver shortage right now in the industry. And so a lot of these fleets are doing everything they can to retain drivers. And that means investing in them, training them, and using this information to help them become better and safer, as opposed to just kind of contributing to additional attrition and turnover.
So it really becomes part of their learning model. That is great. That is great. Any other questions for Nate? Yes, thank you so much. I will send you off to the next step in today. We do thank you so much for attending today's session. From 11 to 12 today, please join our sponsors in the Technology Showcase. Stop in and see them. DQE Communications will be presenting SDWAN for your business. Peter Mulebrook, who's managing partner and head of DevOps Cloud Solutions with Risk Focus, will be in his booth to answer questions from his earlier presentation on big data in the cloud. Our other sponsors will be in their booths to connect with you, answer any questions, and we will have a general networking in the networking room. You may access any of these sessions by using Sched. Also, please join us at noon today for Business as Usual, our program that we hold every day, as we feature 3 companies from our Canadian delegation who will be discussing their technologies. There's a separate registration required, and the link is also available in Sched. We thank you so much for joining us today. Thank you, Nate. Thank you, Miguel. Hope that you all have a wonderful day, and enjoy the rest of it.
Thank you.
Goodbye.
Yeah, thanks.